False beginnings are frequent in the technological world, particularly in the EV business. Every day, you hear about companies promising absurd levels of performance, safety, and affordability based on simply a few lab studies. But, in the end, these businesses are smacked by the realities of the market, and they understand that talk is cheap. This has become such a prevalent occurrence in the business that the list of companies that have failed due to false beginnings is growing year after year. Bright Automotive, AMP, Aptera, Coda, Detroit Electric, Fisker Automotive, and La Eco are just a few of the noteworthy brands. All companies collected a significant amount of money after showing early potential but were unable to keep the wind in their sails due to one single factor. Electric cars are endlessly intricate, and scaling them up is very tough. You'll also need a lot of cash to cover your losses. However, it seems that at least one corporation is not bothered by false beginnings. We're going to look into QuantumScape today. A promising EV company that, according to recent third-party testing, may have produced the battery that will change the EV game. Subscribe and like the video as we begin explaining. QuantumScape stunned the world a year ago. Okay, not like the globe, but very much the tech world, by announcing that they had developed a new kind of solid-state battery that was miles ahead of anything else commercially available. QuantumScape was saying that it had not only built a better conventional battery, but also a superior solid-state battery that met the expectations that most people had for solid-state batteries. Solid-state batteries have been the proverbial holy grail of the EV business for a long time. Many companies have attempted to experiment with them, but none has produced one that has wowed everyone as much as this new battery from QuantumScape. But why should solid-state batteries be important to anyone? What role do they play in the big scheme of things? These batteries are critical to the industry because, unlike conventional batteries, they do not need liquid electrolytes and are therefore safer and denser. They can potentially store more energy per unit volume and charge more quickly as a result of this. As a consequence, the battery will charge and discharge at a quicker rate than any other battery currently available. Solid-state batteries will also be far safer than traditional batteries in the long run. The reasons are straightforward. For starters, there's no risk of an electrolyte leak, and the separator that keeps the anode and cathode apart is made of an oxide that won't burn, which may happen with conventional batteries like lithium-ion batteries. Solid-state batteries are starting to look quite appealing. If solid-state batteries are so wonderful, you're undoubtedly asking why they aren't the industry norm yet. Today's solid-state batteries, on the other hand, are prone to short-circuiting. Dendrites develop while the battery goes through charge cycles. On a chilly morning, dendrites are the tree-like formations that people perceive on their automobile windshields. A short circuit occurs if they breach the separator. The issue is that the dendrites develop at automobile current densities, short-circuiting the battery. The challenge for companies creating these batteries is to ensure that the dendrites do not grow while the battery is being depleted and then recharged. When QuantumScape announced its solution, it looked like they had addressed the issue to a decent extent. The business claimed during their presentation that its battery could travel hundreds of thousands of kilometers and was safe to use in a broad variety of temperatures. Aside from that, the business claims that the battery can be charged up to 80% in only 15 minutes. So, how did QuantumScape pull this off? The simple explanation is that the business worked out that lithium metal anodes would enable it to attain a better energy density than the graphite or silicon anodes now utilized in lithium-ion cells. Lithium metal anodes, according to the business, are incompatible with the porous separators used in lithium-ion batteries. Because they would ultimately result in the production of dendrites, which QuantumScape does not desire. Instead of employing porous separators, the business uses a solid-state separator that it developed. Regardless of QuantumScape's technology's theoretical viability, the firm is still making large, huge, massive promises. And although the EV business was initially enthralled by it, the euphoria faded quickly. Yes, the battery was interesting, but the market would accept their promises with a grain of salt until manufacturing could be ramped up to market levels and third-party testing had been completed on it. Now that a year has passed, the findings are in. QuantumScape's statements were neither exaggerated nor based on inaccurate facts. They were reporting the results of their tests. Mobile Power Solutions have now confirmed all of QuantumScape's promises. a tester who is not affiliated with the company. What's more, guess what? The figures are significantly better than those published by QuantumScape. When QuantumScape released its test findings in 2020, it discovered that its single-layer cells could withstand more than 800 cycles while still maintaining over 80% of their capacity. This indicates that a 300-mile range battery pack could cover an extra 240,000 miles. QuantumScape claims to have achieved the business goal it set for itself. When Mobile Power Solutions conducted the experiments, they discovered that after 800 cycles, the 3 single-layer cells tested had lost less than 10% of their capacity. This implies the battery will be able to go significantly farther during its lifespan. This test is crucial since it is the first and most essential validation of QuantumScape's technology. It also signifies that the company's publicly available test data outperforms all others. The path ahead for QuantumScape is still quite difficult. They've overcome one major stumbling block, but there are still many more to overcome. Improving the separator process in the cell, increasing layer count and multi-layer cells, and, most significantly, improving the volume production process are the main roadblocks right now. Yes, the corporation has shown that its patented technology works. But that's all there is to it. The technology is functional. In the current world, technology alone isn't enough to make things function. They must also be scalable, with a clear and fair path to profitability. QuantumScape will shortly move on to the next stage of development, which will include demonstrating that the technology is economically feasible and scalable. To strangers, this may seem to be a simple task, but it is not. This level of manufacturing almost pushed Tesla out of business, prompting Elon Musk to seek out Tim Cook to acquire Tesla when it was only worth 6% of its current market value. For example, Tesla has failed to meet its Model S car manufacturing objectives for the last 2 years. The same scenario occurred with the Model X SUV, which debuted years late and was plagued by design and technical issues, limiting manufacturing to only a few thousand cars. As a result, even the largest corporations have had to cope with manufacturing concerns that have threatened to derail their development on multiple occasions. QuantumScape estimates that by 2024, it will have resolved all of its manufacturing challenges and will be ready to bring the batteries to the market. It has already begun construction on its first plant in Germany. The facility will produce Volkswagen e-Versys, and solid-state batteries will most likely be used on e-Versys from Audi next Artemis project. Right now, the business is certain that its new batteries will be less expensive, safer, lighter, more energy dense, quicker to recharge, and perform better than standard EV batteries. We have many reasons to believe in QuantumScape today, but in the EV business, no one knows what the future holds. Let us know what you think in the comments area.